In this question, we have to frame a quadratic equation whose roots are 2 and 2 upon 3. If alpha and beta are roots of quadratic equation, then the quadratic equation is x minus alpha times x minus beta. Here we take the given roots, that is alpha is equal to 2 and beta is equal to 2 upon 3. By substituting these values in the given equation, we get x minus 2 times x minus 2 upon 3 is equal to 0. To get the equation, we simplify it further as x times x minus 2 upon 3 and negative 2 times x minus negative 2 upon 3. X square, and we have negative 2x upon 3, negative 2x. While multiplying negative sign with negative 2 upon 3, we get the product has positive, and 2 times 2 upon 3 is 4 upon 3. To get the quadratic equation, we simplify it further by adding the like terms. Here negative 2 upon 3 x and negative 2x are like terms. To add these terms, we add their coefficients. LCM of these two terms is 3, and we have negative 2x and negative 6x, that is equal to negative 8x upon 3. At last we have the equation as x square negative 8x upon 3 plus 4 upon 3. We multiply both sides of this equation with 3, then we have the equation as 3x square negative 8x plus 4 is equal to 0. Let's move to the next question. The next term of the series root 2, root 8, root 18, root 32 is. Let's begin with the solution. Observe the given series root 2, root 8, root 18 and root 32. Here every number inside the square root is a multiple of 2. So we can rewrite the given series as root 2 and 4 times 2, that is 8, and 9 times 2, that is 18, and 16 times 2, that is 32. So we can say that each factor except the first term consists a perfect number, that is 4, 9 and 16. So we have root 2, and under root 4 is 2 root 2, and under root 9 is 3 times root 2, similarly 4 times root 2, so on. Clearly the difference between the first term and the preceding term. Clearly the difference between the term and its preceding term is root 2. Here we take 2 root 2 minus its preceding term is root 2. Similarly 3 root 2 minus 2 root 2 is root 2. So we can say the given series is in AP with the first term root 2 and common difference is equal to root 2. We get the next term of the series by adding common difference to its preceding term. That is, next term of the series is equal to 4 root 2 plus root 2, that is 5 root 2. If we send 5 inside the square root, we have 25 times 2, that is under root 50. So the required option for this question is C. Let us move to the next question. If O is a center of circle, PQ is chord, and tangent PR makes an angle of 50 degrees with PQ, then angle POQ is equal to. Here we have to find angle POQ. By looking at the figure, one can say that angle POQ is equal to 90 degrees. Since it is a perpendicular, this is wrong. Let us begin the solution. Look at the diagram. Here we are given a circle with center O and radius OP and OQ and a chord PQ. The triangle POQ is an isosceles triangle. It is because the sides OP and OQ are equal and it is equal to radius of circle. Therefore, the triangle POQ is isosceles triangle. It is also given that the tangent PR at P makes an angle 50 degrees with the chord PQ. So we have angle QPR is equal to 50 degrees. We know that the tangent at P is perpendicular to the radius OP. That is, PR is perpendicular to radius OP. So the angle OPR is equal to 90 degrees. Angle OPR is the sum of angle OPQ, angle OPQ plus angle QPR, that is equal to 90 degrees. By substituting the value of angle QPR as 50 degrees, we get angle OPQ plus 50 degrees is equal to 90 degrees. Therefore, angle OPQ is equal to 40 degrees. Since the triangle POQ is an isosceles triangle, so the angle OPQ is equal to angle OQP, which is equal to 40 degrees. Therefore, we have got two angles of an isosceles triangle. We have to find out angle POQ, but we know that in any triangle, sum of the three angles is equal to 180 degrees. Therefore, angle POQ plus angle OQP plus angle OPQ is equal to 180 degrees. We don't know angle POQ, so we write it as it is, but we have angle OQP and angle OPQ has 40 degrees and their sum is equal to 180 degrees. Therefore, angle POQ 40 plus 40 is 80 degrees is equal to 180 degrees. Therefore, angle POQ is equal to 180 degrees minus 80 is equal to 100 degrees. So option C is 100 degrees. Therefore, we have angle POQ is equal to 100 degrees, which is option A. This completes our solution. In this problem, we have in a leap year, we have to find out probability that there are 53 Tuesdays in that year. Let's work out the problem. Number of days in a leap year are 366 days. How many weeks and days are there in a leap year? When 366 is divided with 7, the quotient gives number of weeks and remainder gives number of days left over. Therefore, number of days is 366. When we divide, we get 52 is our quotient and 2 is our remainder. Therefore, there are 52 weeks and 2 extra days in a leap year. In each week, we have Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. Therefore, in 52 weeks, we have 52 Tuesdays. Then what about these extra 2 days? The extra 2 days may be Monday, Tuesday, or Tuesday, Wednesday, or Wednesday, Thursday, or Thursday, Friday, or Friday, Saturday, or Saturday, Sunday, or Sunday, Monday. Totally, we have total number of possible outcomes are 7. Here we take n of s is 7. Here what we suppose is to find the probability that there are 53 Tuesdays. Let E denote the event that there are 53 Tuesdays in a leap year. Therefore, we have 52 weeks. That means we have 52 Tuesdays. To get 53 Tuesdays, the extra 2 days must be Monday, Tuesday, or Tuesday, Wednesday. Therefore, number of favorable outcomes to event E is 2. That is, n of E is 2. The probability that a leap year consists of 53 Tuesdays is P of E. It is the number of favorable outcomes to E, that is N of E, to the total number of outcomes, that is N of S. We have the values N of E and N of S, which are 2 and 7. Therefore, the required probability is 2 upon 7. This completes our solution.
Let's move to the next problem. If a tree of height 21 meters is broken but not completely separated, the top of the tree touches the ground at an angle of 30 degrees. Then find the height at which the tree was broken. We have options as 5 meters, 6 meters, 7 meters and 7 times under root 2 meters. Let's work out the problem. Coming to the question, here we are given a tree. Let us assume it is a tree AB of height 21 meters. Let us assume the tree is broken at a point P, which is at a distance of x meters from the ground. Therefore, we have the height of broken tree, that is AP, is equal to x meters. In this problem, we have also given the top of the tree, that is B, touches the ground at an angle of 30 degrees. Therefore, it has broken at P. So from this point, the top touches the ground by making an angle of 30 degrees with the ground. Let the top, when reaches the ground, at a point B dash. Therefore, we have angle AB dash P is equal to 30 degrees. If we look at the figure, we can say that triangle AB dash P is a right angle triangle. And the length of the hypotenuse B dash P is obtained by subtracting height of the tree from the total height of the tree. That is, total height of the tree is 21 meters and the height of broken tree is x meters. So totally we have the length of remaining tree, that is hypotenuse of triangle, is 21 minus x meters. By using appropriate trigonometric ratios, we can find the height of the broken tree, which is x. Which trigonometric ratio gives us relationship between hypotenuse and perpendicular? Such a trigonometric ratio is sine. Therefore, sine of angle 30 degrees is equal to perpendicular, that is AP upon hypotenuse, which is B dash P. We have already got the values of AP and B dash P as x and 21 minus x. That implies sine 30 degrees is equal to AP, which is x, and B dash P is 21 minus x. From the tables, we have the value of sine 30 as 1 upon 2, which is equal to x upon 21 minus x. By cross multiplication, we have 1 time 21 minus x is equal to x times 2. That is equal to 21 minus x is 2x. By adding x on both sides, we get 21 is equal to x plus 2x gives us 3x. Rearranging LHS and RHS, that implies 3x is equal to 21. By dividing with the coefficient of x, that is 3, we get the value of x as 7. What we have assumed in the figure is x is the height of broken tree. Therefore, the height of broken tree is 7 meters. If we look at the options, here C is our answer, that is 7 meters. This completes our solution.
Let's move to the next question. Here two dice are thrown simultaneously and the probability of getting doublet is, we have some options. Let's work out the solution. On throwing a single die, we may appear one of the numbers as 1, 2, 3, 4, 5 or 6 on the upper face of the die. So, the number of outcomes when a single die is thrown is equal to 6. Similarly, when two dice are thrown, the possible number of outcomes of the experiment are in the tabulated form. Look at the each ordered pair. Here, the first number in each ordered pair is the number appearing on the first die, and the second number is appearing on the next die, that is second die. Totally, number of outcomes when two dice are thrown is equal to 6 times 6, that is 6 square, which is equal to 36. When two dice are rolled, the numbers appearing on one die is equal to the number appearing on the other die. Then such a pair is called a doublet. If we take 6 has a number on one die, if 6 appears on the same die, then 6, 6 is a doublet. If we take E is the event of getting doublet, then the number of outcomes favorable to an event E is 6, which are 1, 1, 2, 2, 3, 3, 4, 4, 5, 5 and 6, 6. Probability of getting a doublet, that is probability of E, is equal to number of outcomes favorable to E divided by total number of outcomes. We have number of outcomes favorable to E is 6 and total number of outcomes are 36, which is 6 upon 36, 1 upon 6. Therefore, the answer to this problem is 1 upon 6. Let's move to the next question. Here the radius of a sphere is r centimeters and the sphere is divided into two equal parts. The whole surface area of two parts will be. Here we are given some options and we work out the problem. First of all, what is a sphere? A sphere is a set of all points in a three-dimensional space which are at an equal distance from the fixed point. The fixed point is called center of sphere or origin. Here we have marble as an example of sphere. Coming to question, we are given the radius is r centimeters. Then it is divided into two equal parts. If we divide a sphere into two equal parts, then we form two hemispheres. The difference is we obtain two circles above one hemisphere and one circle below one hemisphere. Then the whole surface area of two parts is equal to surface area of complete sphere plus area of this circle and area of the circle above this hemisphere, that is area of another circle. In all these cases, we have the radius is r centimeters. We know surface area of a sphere is 4 pi r square and area of a circle is pi r square and the area of another circle is pi r square. By adding all this, we get 6 pi r square as the total surface area of two hemispheres, which corresponds to option B. This completes our solution. Let's move to the next question. A steel wire, when bent in the form of a square, encloses an area of 121 centimeters square. If the same wire is bent in the form of a circle, then we have to find out the circumference of the circle. Let's work out the problem. In the above question, we have a steel wire of unknown length. In the first case, it is bent in the form of a square and we are given area of square is 121 centimeters square. We define area as a surface covered by the closed figure. If we take the unknown side of a square is s, then its area becomes s square is equal to 121 centimeters square. By applying square root on both sides, we get the value of s is equal to 11 centimeter. It is because 121 is a perfect square, so its square root is 11. In the next case, the same steel wire is bent in the form of a circle. It should be noted that the same wire is used to form a square and circle, so the circumference of the circle is equal to perimeter of square. We have the side of square is 11 centimeter, so its perimeter becomes 4 times its side, that is 11, which is equal to 44 centimeters. Therefore, option B is our answer. Let's move to the next problem. If 2 upon 3 and negative 3 are the roots of the equation ax square plus 7x plus b is equal to 0, then we have to find the values of a and b in the given equation. Let us discuss how to frame a quadratic equation when the roots are given. We already know that a quadratic equation ax square plus bx plus c is equal to 0 has two roots, and they are given by x is equal to minus b plus or minus under root b square minus 4ac divided by 2a. Here b square minus 4ac is called the discriminant. If we take alpha is equal to negative b plus under root b square minus 4ac upon 2a, and beta is equal to minus b minus under root b square minus 4ac by 2a, sum of the roots is equal to alpha plus beta, that is minus b plus under root b square minus 4ac upon 2a, and we have the value of beta as negative b square minus 4ac under root upon 2a. Both contains the same denominator, that is 2a, so their LCM is 2a. When we add these two, under root discriminant are cancelled out. We left with negative b plus negative b, that is negative 2b. By cancelling 2 on numerator and denominator, we get the sum of the roots as negative b upon a. This is a very important result. Now let us find the product of the roots. That implies alpha times beta, which is negative b plus under root b square minus 4ac upon 2a times beta, which is negative b negative under root b square minus 4ac upon 2a. In fractions, we learned that the product of two fractions is the product of the numerators divided by product of their denominators. Therefore, on denominator we have 2a times 2a is 4a square. If we look at the numerator, here negative b plus under root discriminant, here we have negative b minus under root discriminant. It is in the form of a plus b times a minus b, which is equal to a square minus b square, which is equal to negative b whole square minus under root b square minus 4ac whole square. On simplifying, negative b square is b square, negative square root and square get cancelled, therefore we remain with discriminant, that is b square minus 4ac upon 4a square. By distributing negative inside the bracket, we have b square minus b square. The product of two negatives will be a positive, and we have 4ac. B square and negative b square cancelled out on numerator, and we remain with 4ac upon 4a. 4 and a in numerator and denominator are cancelled. Therefore, the product of the roots is c upon a. Therefore, the product of the roots is alpha times beta is equal to c upon a. Therefore, if alpha and beta are two roots of the quadratic equation ax square plus bx plus c, Then sum of the roots is negative b upon a and product of the roots is c upon a. Why we calculated sum of the roots and product of the roots? It is because to frame a quadratic equation when the roots are given. Suppose we have alpha and beta as roots, then the quadratic equation is x minus alpha times x minus beta, which is equal to 0. Let us distribute x to x minus beta and negative alpha to x minus beta. X times x is x square and negative beta x and negative alpha x. Here the product of two negatives will be a positive, therefore plus alpha times beta is alpha times beta, which is equal to 0. On taking negative sign and x as common, we have alpha plus beta times x plus product of the roots. Therefore, by calculating their sum and product and substituting in this equation, we can obtain a quadratic equation. Let us do that. In this question, we are given two roots, that is alpha is equal to 2 upon 3 and beta is equal to negative 3. Let us find their sum. We have alpha plus beta is equal to 2 upon 3 plus of minus 3, which is 2 upon 3 minus 3. Here LCM is 3 and we have numerator has 2. Coming to this, we multiply numerator 3 with 3 in order to get the denominator as 3, which is 9. 2 minus 9 is minus 7 upon 3. Similarly, product of the roots is equal to 2 upon 3 times negative 3, which is equal to negative 2 upon 3 times 3. 3 numerator and denominator get cancelled out. We have the product of the root as negative 2. We already frame a equation whose roots are alpha beta is x square minus sum of the roots, which is alpha plus beta times x plus product of the roots. By substituting these values, we get the equation x square negative sum of the roots is negative 7 upon 3 times x plus product of the roots is negative 2, which is equal to 0. On simplifying, we get x square. The product of two negatives is positive, therefore 7 upon 3 times x and plus of minus 2 is minus 2, which is equal to 0. By multiplying both sides with 3, we get the equation as 3x square plus 7x minus 2, which is equal to 0. Let us compare this equation with the given equation. Our given equation is ax square plus 7x plus b is equal to 0. We obtain equation as 3x square plus 7x minus b is equal to 0. On comparing the coefficient of x square, we get the value of a is equal to 3, and on comparing constants, we get the value of b is equal to negative, which is equal to negative 2. This completes our solution.